Good morning. Welcome to the July ICOR webinar on managing storage and driving efficiencies. Today's presenter is Dennis Wenk from Dimension Data Americas. Dennis?
Hello, everyone. I'm delighted to be here and delighted to do this webinar for ICOR. I'd like to share with you my credentials. Like Margot has said, I'm a principal consultant with Dimension Data. I work in the physical infrastructure organization for Dimension Data, and I provide focus primarily on supporting next generation business continuity and operational resiliency for them. But in that respect, I provide a lot of information with relative to storage and what storage is. So, as I said, I'm delighted to be here today. I've asked Margot to interrupt me at any time if there's questions that we have that I can answer during the presentation. I won't wait to the end. I think it's more constructive if we handle the questions as they come up, so that you get your questions answered as they're needed. So let's kick this off and start into the presentation. And there we go. So our objectives are, we want you to learn why digital storage requirements are critical to the environment. I'm going to go over some virtualization cloud architectures that are out there, storage trends, and how we manage those issues, and how you can drive some efficiencies in a storage environment. And you may not be necessarily responsible for storage. However, if you are, however, even if you're not, it's helpful to understand what's going on behind the curtain with storage, because it's quite a complex technology that we deal with. So storage trends today. The reason storage is so important today is the data growth. We have very high growth per year. Storage is it's getting cheaper, but the growth is outpacing the investment that we have. And because the way storage is organized today, and because the way data is changing, and as quickly as it's changing, that poor utilization is increasing the investments that we have in storage. So it's important to manage the data better. We see an increasing adoption of server virtualization and virtualization of desktops, and that virtualization at the server layer, is driving demands for higher performance from storage. So I need the storage, I need access to the storage, and I need access to the storage faster than ever before. Virtualization also can require, it also requires more efficient use of the storage. So where I place the storage, how quickly I can expand the storage, how elastic that storage is, how flexible that storage is all important to delivering service to your end customers. And then there's an increased cost of expenditure. The cost to manage storage exceeds the cost of purchasing it. And I think if you, the way I've laid out today's presentation, I think you'll have some context on why it's so difficult and so challenging, not difficult, but challenging to manage storage today. And that tedious manual intervention and the lost revenue that we have when systems are due to planned downtime to expand storage in our environment is also costing organizations a lot of money. So I thought we start out with a poll for the people that are on the webinar today. And do you have any of these concerns? And please denote any and all that apply. How you can deliver storage on physical and virtual platforms in a hybrid storage environments. If you have undiscovered or waste storage, wasted storage. Just take a moment, look through the 4 polls, and let's take a poll and see how many of these have these concerns.
We've got about 20% of folks on the line have voted so far. We'll leave it open for a few more seconds here.
So Margot, is everyone familiar in how to vote?
Yeah, they're coming in. We've got numbers are jumping up. We got about 40% in, 53. We'll leave it open for a few more seconds. But if you are having problems voting, if you can use the question box or the chat box, we'll make sure that you get the help that you need. All right, we got about 70% voted. I'm going to close the poll now. And share it. And Dennis, you'll see that looks like 60% of the folks, you know, the first one, how can I deliver storage on a physical and virtual platforms is the major concern.
The major concern. Okay, cool. Well, we're probably going to get that later on in the presentation, but at least I know where you're all coming from. It's difficult in a hybrid environment as we move from physical from physical to virtual platforms on how we can manage it. To some extent, virtual makes things easier. To some extent, it's another layer of complexity that we have to manage. So let's move on. So what is storage? Well, there's 3 areas that I've laid out on what storage are. Certainly, storage can exist inside the server, just like in your laptop or your home desktop computer. There's a physical unit of storage that's in that server, so it can be internal to the server itself. The next is external drives. So just as you have external storage where you can plug in a thumb drive, you may have a CD disk, even in a hybrid IT environment, you have external storage arrays that are out there in which the servers are just standalone devices that are accessing storage that is in some type of array over a network. And then there's the network storage. That network storage that could be in the cloud. It could be attached via some type of Wi-Fi network. It is network attached in any effect. It can be a private network, which is referred to typically as a SAN, which is a dedicated network just to access storage arrays. Or it could be your local area network is attached to some network storage, and we'll get into what that storage is as we move through the presentation. So what are the business needs? And I see three business needs that organizations have to manage storage better. And one is to reduce the downtime. And this is not unexpected downtime. This is downtime that we need to plan maintenance. It's to plan growth. It's to change storage structures. It's to add new storage. These things become quite onerous in an organization as the storage begins to grow. In fact, I've seen many storage environments in which organizations are growing so quickly that all they have time to do is add new storage because they're reduced to adding that storage during a weekend when there's very little activity. The next business need that we have is reduce the hardware cost. The CapEx cost of actually going out there and buying a petabyte of storage can run into millions of dollars. It's not going down to necessarily going down to Fry's and picking up a 2 terabyte drive for $49.99. It's a very important thing to do is to manage and reduce the CapEx costs. And then the third area is certainly the IT operating expense. And the IT operating expense, as I said earlier, it costs more to manage the storage than it does for the storage itself. So the amount of people that we need to manage the storage, we need to do more efficiently. They need to have the tools available so they can do more things online during regular work hours. As I said, I've run into organizations where I've seen the storage engineering staff not have a day off, not have a holiday off in over 2 years, just because of the management of this. So this is the important business needs that we have. The key IT issues is, how do we gain visibility? Who's using the data? Where are they using the data? How are they using the data? And what type of data is it? It provides the necessary information that we need in order to manage that data properly. Then to reduce recovery time. So I want to make sure that if something fails, I not only have access to that data, that online data that I need, but I have access to that data very quickly. So the increased availability is an important aspect. And then improve the workload, the workload performance. If I can increase the performance to the drive and how the drive or how the storage is actually grabbing the data, I can provide faster output to my applications and my users that need that data. So storage growth, what we've seen is that storage has actually grown at a compound annual growth rate of close to 50% a year. It's very fast growth rate. What we're seeing, as we'll talk about unstructured data, we're going to talk a little bit about what unstructured data is later on in the presentation, but what's growing the quickest is that unstructured data. We still need to store it someplace. It still needs to go someplace, and that annual growth rate is at 50%. And that's coming from the analysts out there, the Gartners, the IDCs, the Tech Alpha groups are saying that in most cases, organizations grow at about 50% a year. The challenges are this. We've got a lot of different servers out there that are running multiple operating systems. AIX, you may have a Unix environment, a HP Unix. You could have a Solaris device. The Penguin is our Linux types of operating system. And then we've got Microsoft sitting out there. So servers are running different operating systems in our environment. We have a variety of storage vendors out there. You have HP, Hitachi Data Systems, IBM, EMC, NetApp, and all these vendors have a proprietary way in which they manage their arrays. They're different for each one of those vendors, and they don't cross across those vendor lines on how they do that. And then we have the applications on top, the applications that actually need to access those that storage data that resides on the storage. To make it more complex, there's a multiple number of tools and flexibility tools that we use in different operating environments to manage the storage that we have. And different tools that we have from each of the individual vendors with different names and different nomenclatures on how they manage this storage in their arrays. And this creates not only a level of complexity, but it means that we have to be managing a number of different platforms and a variety of different vendor-specific tools that are independent on how those applications are actually growing their data and where we place it. So this is part of the complexity that we get into with managing the tremendous growth that we have in the storage area. So I have another poll here that I'd like to go through. I'd like to know if you know what your individual growth rate is, and if you do know what your growth rate is, in the poll, is there a way that they can, Margot, that they could actually tell us what their growth rate is? To see, I guess what I would like to know, is it under 50% or over 50%?
So if you mean independent of responding to the poll, Dennis?
Yes. Yes.
Yeah. So if they wanted to put any of that in the chat, they could do that.
Okay. So let's just go if people are over 50%, just put in the chat that your growth rate is over 50%. Are the polls enabled?
Yes. Yeah. So the poll's enabled, and we've got about 56% people reporting, and so far nobody's over 50%.
Okay. All right. Well, that's good.
So we'll give it a couple more seconds, and then we'll close it. Okay. I'm going to close the poll, and you'll see the results here. So it looks like most people don't know, and
Okay.
then nobody was over 50%.
Okay. Okay. Well, if you don't know, you wouldn't know if you're over or under. So.
Yeah.
Good to know. All right. So it's important to know because it's costing your organization money. That's the key here. So, well, let's continue on. So let's get a little bit into the background. The poll's closed, right?
Yes.
Yeah. Okay. Some background on storage then. Okay. So let's start out with arrays. So what we have are arrays, which are a group of, if you think of the disk drive that's stored inside your laptop or your desktop computer, an array is just a lot of a chassis with a number of different slots in it, and that slot holds the physical disk drives that are there. In order for a server to get to those arrays, they're not directly attached. They're attached through switches. This is either the storage area network or a switch that is actually your local area network. The storage area network is a private network. It only serves the storage, and it provides high volume, very fast traffic, I/O traffic back and forth from the servers to the storage arrays. The reason you have that, of course, is performance. You put it on a local area network, the traffic that you'll be competing with is the local area network traffic, which is not just storage I/O traffic. Was there a question, Margo?
No, we don't have a question.
In order for the servers to access the storage, one of two things are necessary. There needs to be a host bus adapter, an HBA, for a storage area network, or a network interface card, same kind of network interface card you would have on your server if you're on your laptop, in order to access the local area network to get to your data that's on the storage. The storage the data is stored on platters, physical platters. So the picture that just came up on the bottom of the screen there is we have sectors, we have tracks. These are physical layouts of what the platter looks like. And basically the platter is multiple disks that are strung together. Usually, I believe usually they're in odd numbers. Anywhere from 5 to 7 is what we have. And then what we're starting to see on the storage area, what we're starting to see on the storage area, I'm having difficulty going back. Okay, we just won't go back. We're starting to see solid state storage, which is no spinning disk, but it actually provides a very fast access to your data that's stored on that non-volatile solid state disk that we have. The disks are laid out in what they call RAID. All right, and I wanted to go through quickly, just very briefly what RAID is. It's important to understand. RAID's really just stands for Redundant Array of Independent Disks. And what that means is that we're going to lay out those disks, those platters, in this array configuration. And what RAID does is RAID, typically you'll see a RAID, my experience is we usually see either RAID 10 or RAID 5. And that's why the pictures on the bottom of the screen represent RAID 10 and 5. What 10 does is what RAID 1, RAID 10, RAID 0 do is it mirrors the drive. And the reason we have RAID, it's a physical attribute of the storage itself. It's not something that you necessarily control with software from the server. It's done at the time that you provision your software. And what you're doing is setting up a mirror of your storage drive. So if that drive fails for any reason, it can fail over. And what RAID 1, 0, and 10 basically do is set up a mirror so that if you lose a drive, you can quickly switch over to another drive with the exact same data and lose very little time. All the addressing is there, everything is there. It's all handled by the array itself. There's nothing that you have to do physically. On the RAID 5, what is done is the data is striped across multiple disks to save disks. In RAID 10, what you're doing is you're reducing. If you've got a petabyte drive, you really only have usable on that petabyte drive basically a half a petabyte of data you can store on it, because you're mirroring that half a petabyte of storage with your mirror. So you only have room for a half a petabyte of storage. To increase the efficiency of the drive, we can do what RAID 5 does, which is basically stripe data across multiple drives, so that if you lose a drive, you can go to a spare drive, rebuild that spare drive, which means it's going to take some time, but it is usually very quickly to use with the algorithms that are set up by the array, and you have more efficient use of the capacity, but what you're paying for is performance, because there is a rebuild time associated with RAID 5. So usually what you see in an environment is when you provision the data, when it's first set up to be used, it'll be either provisioned as RAID, a set of disks will be provisioned as RAID 5, a set of disks will be provisioned as RAID 10. That typically, from an array perspective, does not change. So if your entire array is RAID 10, you will have to reprovision that entire drive if you want to put RAID 5 on it, which takes time and is very cumbersome. Which is our first level of complexity that we have. How should the data be organized on the drive itself? Should it be RAID 10, RAID 5? Should it have striping? Those things need to be thought about, and in order to know that, we need to know a little bit about how the data is going to be used. Example of a RAID structure. All right, so what we see on the top is the physical drive itself. The physical drives are laid out with 14 different physical drives, which are represented by the gray areas that are on the top of the screen. Those gray areas are then configured into gray groups. RAID groups. So this would be RAID 10. I'm going to mirror, as you can see, the two that are at the top are mirrored into one area of LUNs, which are a logical unit that is used by your application to access the data in those RAID groups. So we've created 6 RAID groups out of the 14 drives that we have. So that's those 6 RAID groups are represented by the blue below it. The 2 on the upper left-hand side have not been provisioned. And the reason they're not provisioned is they're spares. They're spares because the disk drives fail. And there's multiple types of disk drives that you can put in your array. You can put in a SATA drive, which doesn't, remember that the physical drive itself is actually mechanical. It wears out. Its mean time between failure on a SATA drive is less than a SAS drive, for instance. So for high speed, high access data, you want to outfit the array with SAS drives rather than SATA drives. However, SAS drives are much more expensive because they cost more to produce. So what we've created here is a RAID group of 12 array-based LUNs, logical units, that will be accessed by the applications itself. So what's important? If I've got to get to my drive, I want to have multiple paths to that drive, which is another reason that we like to set up high access data to arrays using multiple path options, which requires now 2 HBAs, 2 switches, and 2 ports on the other side of the environment. But the reason that we have that is to optimize the performance, so we know we can always get to the data, to optimize any kind of failover that we have to get to that data, and to manage that connectivity, which means that if I have to do, as a storage administrator, not only do the applications have to get to that array, but as a storage administrator, I have to use my tools to get to that array as well. So I go over the same paths to get to that array. So those are the 3 functions that we have, and one of the reasons that we do multiple pathing is critical because of performance related issues. There are 2 types of multi-ported arrays. One is an active-active path, which means I have 2 active paths. I can I have automatic failover. If I can't get to the data with one path, I can automatically go to the other path. So I have some type of load balancing as well. So if one path gets congested, I can go to another path. There is a way to do active passive, which sets up the path as a secondary path, but you're constantly using path 1 in this case. The secondary path is only used if you lose path 1. It doesn't provide as much load balancing. If you need that load balancing, it's typically the same cost, physical cost, because I have to put in my array, my port, my switch. I have to have 2 of them. But the way I fail over is going to take more time as well. So most people, if they have this environment, are going to go active rather than active passive. It's important to remember I've got multiple servers out there. I also have multiple access from a server that may need to access data that's on multiple arrays. So when I start to fill up the multiple arrays, I need more HBAs because I have that HBA as a path to an array. And if I have another array, I'll have to have another HBA. So the cost of setting this up in this environment is also important. And I may want to put in for redundancy purposes, another switch, and cross-connect those switches. So if the switch fails, that I can eliminate any single point of failure that I may have in the environment. So I get into a little bit now of what storage virtualization is. It's a little bit different than the server virtualization we've seen from things like VMware. In the case of storage virtualization, the cloud represents multiple arrays and multiple different types of environments that I have from different vendors and different arrays out there. And what I want to do is use all of that data as a pool. And I want the ability to manage the pool of data rather than individual drives. And remember, we said earlier that each vendor, each array vendor has its own method of managing their storage on their array. So I need to access multiple tools. To do that, I need to have knowledge of how those tools work, and they all do not work the same way. So it is important that from an efficiency standpoint, if I can standardize around a specific tool that I can use to manage all of my data in that environment. That comes into where the first level of virtualization that we have is volume management. And that volume management on the array is usually resident on the array device itself. The array device itself is made up of a head of string, head of an array, and that array has that volume management in it. And contained within that volume management is the software that does the storage management for the LUNs. Now, the application operating system are accessing the data in terms of files that access volumes, and the volumes are actually the area of virtualization from the physical disks and the LUNs that are down there. So I have volumes that are made up of physical disks and LUNs that are sitting out on the spinning disks that are there. And volume management does the online administration. It manages your configuration. It may provide an area of where we want to put the data for high availability, how we span the data, doing that striping across the physical disk that we talked about before, and how we do load balancing. And all that is managed by your volume manager, which in most cases from the array vendors are done at the array level. Now, there are three types of storage virtualization from this volume management side. The first is storage-based volume management, and it's the way I described volume management in the previous slide. The array itself has the software that does the volume management on it, which means if you have different types of arrays from different vendors, they use different software to do their volume management. Now, the volume management and the way it speaks to the servers are quite the same because it's accessing a volume. But what happens on the disk drives and the physical disks below it and the LUNs are all contained within the software that's running on the storage array. If we do a host-based volume management system, now I can attach different types of storage vendor products, different arrays from different vendors, because I have a common array, volume management software that's running on the host server. Now, the drawback to that is that volume management is now done at the server, so the workload on the server gets greater. However, at this point in time, the way the servers are growing and the capacity of servers and the performance of servers, it's very lightweight. But it does provide a layer of virtualization that allows you to now pull data across several vendors' storage. And then the third type of virtualization is network virtualization, where the volume management is actually done in the switch. When it's done in the switch, the problems that you have is how do you expand the switch? On the server side, that software can be replicated and is actually a resident part of the operating system. But as you go to the on the network side, it becomes resident within the switch, which means that you've got to have a common switch and that common that common volume management. So I rarely see any of that virtualization actually happening on the switch side. Two most common areas are storage-based, actually let's use what I get from the storage vendor, or host-based, which is happening at the operating system level. So virtualization layers, I'm going to go through this relatively quickly. What we have are different operating systems, different users, applications and databases that we have at our top layer. Volume management is the way that your operating system, your applications, your databases actually is going to talk to the physical devices in the lower layer that we see on this picture. It does that with virtual storage devices and the way it lays out its volumes in the volume management area. So it makes sense to put this directly into the operating system rather than put it into the array, although it's always going to be on the array side. On the array side, then, we have how the disks are laid out, either in RAID 5, RAID 10, any of the other RAID environments. Usually 5 and 10 is the way to do it. Different types of brands, different vendors, vendor A, vendor B. JBOD is just a bunch of disks, which may have something that you could put together and build yourself, or a knowledgeable storage administrator could build themselves using cheaper, like I said, SATA drives without the overhead of the branded arrays. And then, of course, we talked about solid state disks, which are not spinning disks, but actually use the same software that you use for multipathing LUNs devices and volume management. However, it has no spinning disk and no mechanical devices that are running down there. So there's three areas that we have. What we want to do from a storage virtualization perspective is manage that bottom layer as if it is one pool of storage, and that I can lay out my multipathing and my LUNs in a layer above it using our volume management system to do that. So they can access storage wherever it may reside based on the volume manager that's running in the environment. And that's the important component of storage virtualization. So there are ways to virtualize a multiple vendor storage device, but that storage device, one of the arrays from one of the vendors will have to be the primary source of that data, because it's providing that volume management. So if we can disconnect that volume management from the storage device itself and actually put it into the operating system, we provide much more flexibility to get to any of the storage that we see on the bottom layer. The advantage of storage virtualization is how we move that volume management layer that you see above it. And then, of course, the operating systems, the applications, and the databases are talking to your volume management system using a file-based system that they have, typically. So we're going to have another poll, and what I'd like to know is, has your organization defined owners for all of your data? Do you know who owns the data that's sitting on the storage today? So if we can take a couple of minutes, Margot, and let's poll the people to find out if they have owners to their data.
Yep, the poll's open. We got about 35% of the people have responded thus far. And so far, half of them said yes for all data.
Cool.
So we'll leave that open for a few more seconds here.
Well, that's good news.
We're going to go ahead and close the poll. And it's almost evenly split, but yes seems to be edging ahead a little bit.
That's good. That's good, because that's been one of the major areas that we have, is we don't know who to go to actually ask why the data is growing so fast. If you don't know who owns the data, how do you get to those people? That how do you start to manage the data, but you don't know if you can delete it, if you can move it to a disk drive or archive it. So the poll is closed.
Poll is closed. We got about 20 minutes left, and we'll move ahead.
Okay, I'm going to go through the optimized storage then as quickly as I can. So let's talk a little bit about storage management. What we want to do is manage a hybrid storage environment effectively and efficiently. We need to know what each application uses, create some kind of accountability, and have some way to plan for growth and capacity. We want to be able to reclaim any underutilized assets, either deduplicate it, resize it, compress it, move it into a thin type of environment. We're going to explain all these as we go through. And there may be a way that we can use commodity storage, that JBOD that I talked about before. Is there a way that I can build a JBOD device, get rid of all the overhead storage of that volume management, because I'm going to do my volume management in my operating system, and then switch vendors and switch data non-disruptively, so I can move data in and move data out of that environment, and place the data on the right tier of data when you need it there. The one thing about data is it changes state over time, which means that I can have a very high volume data that needs to be on expensive arrays for the first 30 days of its life, and after the first 30 days of its life, it tends to go dormant. And when it goes dormant, I don't want to put it on that that high tier of storage, because it costs more money. So is there a way I can move the data to a lower tier of storage, provide that higher tier of storage to more active data, and therefore efficiently use the storage that I have in my environment based on the workload characteristics, the data characteristics, and policies that I have in my company? Okay, so we talked a little bit about the benefits of standardization. If I can take that standardize on an environment, I can now train all my people in different types of on one area of storage management, regardless of the vendor, HP, Hitachi, IBM, EMC, NetApp that I have down there, and start to manage the risk better. I can do testing, I can do change management, I can drive some productivity increases, I can do more with less in the environment that I have. And that provides cost savings throughout the organization. Production virtualization, some of the things that we began talking about with the volume management, is one of the first areas to start. Thin provisioning. x86 is really the Unix, Linux operating systems, and what's expanding, where that data is going, being driven by on a server side. And then storage optimization. How do we optimize that environment that we have today? So optimize storage. One is we've got to have end-to-end visibility. We're going to talk a little bit about the difference between the physical drives I have, how I logically lay them out, what's actually claimed in the environment, then what's consumed, what's used by the host, and actually what the application sees, and plan for that capacity. So how do I get the visibility to know when I have wasted space or space that I can reclaim? Then how do I drive storage efficiencies and maybe use some what we call thin provisioning devices, dedupe, compress, resize, and stay thin, and then reduce the acquisition costs, right? Use some commodity storage, lower cost storage that doesn't have all the overhead of the software, because the software now I moved out into the software layer, into the server layer, rather than storage layer to do that. By doing that and providing that volume management, it allows me to place data on the right tier at the right point in time. If I keep it within the storage environment, I'm staying within the array only, and that reduces the effectiveness that I have on that storage. So it's important to understand how your storage is actually being used. We talked about the physical drives that we have, starting on the left-hand side of the screen. The physical side, remember, we had some of the overhead, and what we're representing there on this picture is the physical drives that I've laid out is, say, a RAID 5 environment, where I can drive the efficiencies, but I still need some overhead in case I lose those spinning disk drives itself. And then there are some unprovisioned capacity that I have that I can actually use later on if I need to expand some of the storage that I have. On the logical side, then I take that physical and actually a little bit of overhead and unclaimed space that I have, that I logically would give, the storage team would now give to the server team. And the server team now has visibility into that logical area that it has. Now the storage team is going to say, gee, you know what? It's going to take me some downtime if I don't allocate enough storage, and I really don't have enough experience to know how much storage I need to allocate. So I'm going to over allocate. And that means that I have some unclaimed, over-provisioned storage out there that's really free space. I could use it if I knew I had it, but it's so cumbersome, given the current environment that I have, to grab that storage space, and it takes so much downtime for me to do it. I'm just going to over-provision it. It's easier to do that. Then we have the host storage, which we may have some ways that we're misusing that storage, which means that I'm using high performance storage for an application that actually I do once a month, and that data rarely changes. So I really don't want to have that on high speed, high performance types of drives. So I'm misusing that storage, and you know, typically about 50% of that, a little bit less than 50%, let's say 30% of that is misused because I don't have the ability to use any of the other storage that I have out there, or to move between different storage tiers. And then I have what's
Dennis?
Actually used by the, yes.
Yeah, we have a question. Sorry to interrupt.
Okay.
Will storage virtualization degrade I/O performance on my SAN?
No. No, it actually, the I/O performance on the SAN should not be, there should be no degrading I/O performance on the SAN at all. The volume management is done in the operating systems. Once that's done in the operating systems, the I/Os won't change. It doesn't come from from volume management. It comes from accessing the data from the application itself. So no, it does not. Okay.
Thank you.
And as we move down to the, I hope I answered that. If I didn't, ask it a different way, and I'll go. But it does not degrade performance. And then we have what's actually used by the application. So what you can see is that at the application used, what we're trying to represent here is what is physically available could be used more efficiently from the organization. So we can increase storage utilization by 50% if we could consume the data differently. And we can, by consuming that in 50%, if we have a 50% growth rate, means we can stop buying storage for almost a year. That reduces CapEx, it reduces OpEx from a managing that storage growth perspective, and it's a better way to go for the organization. This is just a representation of why I need clear visibility to where the storage is to accelerate any of the operations that we have, so I know who's using data where. It eliminates any user errors with automated operations, so I can start to automate the policies of moving from different sites into different stacks, into different tiers that I have, and maximize storage utilization, which means that if I have storage that's available from that happens to be laid out in a RAID 10 environment that's sitting on a different drive, but I don't know how to get to that different drive because I'm using that volume management differently and managing it at the host layer, I can actually get to that environment and use that excess data that's there. Now, as you would see, data is laid out typically in blocks. Those blocks get fragmented, meaning as we start to write and delete and write and delete, we've got spaces that occur, and we need to go through a process, a utility process, to actually defragment these different fragments that occur during normal use. This is called fragmentation and defragging the drive. One area of caution that I have is once you start to defrag your environment, wait till it finishes. I had a large customer down in Chile, a large bank in Chile that had a defrag that was happening that took longer than they expected. They canceled it in the mid defragmentation mode. That's happening inside the array itself. The pointers got all screwed up, and they were down for a week trying to remanage the storage that they have there. So once you start to do a defrag, wait till that utility function is done. Multiple tiers of storage we started talking about a little bit earlier, where 10% of your storage is really high volume storage. That should be in solid state storage disks. They're very expensive. However, they provide extreme performance. We may need another 25%, which is mirrored HDDs, hard disk drives. Those hard disk drives, remember, that's a RAID 10 environment. 40%, most of the data that we have, 40% can be laid out in a RAID 5 type of environment, and some simple hard disk environments that I have in RAID 4 that are much cheaper, that doesn't get a lot of access, that I can actually move to. And what I want to do is use these multiple tiers and move my data relative to its value based on the physical tiers that I have on the storage devices. So I get better quality of service at the same time. I get lower cost if I can do this and if I can automate that process of doing that. Deduplication and compression, the difference about compression, compare and contrast. Compression is basically taking the space that we have, reducing that storage space by as much as 70%. This reduces the amount of space that I need for both my replication or any snapshots, point-in-time snapshots that I have. It improves the performance of the storage because the data is actually condensed on the drive itself. On deduplication, what deduplication is an algorithm that says that I have one master block of data, and that any changes to that master block of data is only managed for those different specific areas. So if I have multiple test dev environments and I want a different vision of my database, that I really can have a master database and just have that different vision of the database and manage that different vision and the characteristics of that database differently, where I can use the master and then use just the changes rather than making complete copies of the database to do my test dev type of environment. So compression and deduplication are two to have. Thin provisioning is a way that I can actually basically lie to my environment and tell it I have more storage than I actually have. So I can so that the server admins can actually tell me they need 2 petabytes only, even though they're only using 1 petabyte. I can take that petabyte not using and actually use that use that for another environment. That's called thin provisioning. It's a way to lower cost, use your efficiencies. The array itself has to be thin friendly, which means it has to be resident within the array itself, the software that's done within the array to get that done. But basically, it's a way that we can tell the array that it has more storage than it actually does have physically. So centralized management is a way to deploy applications and optimize your storage and reduce your costs over time for the organization. Talked a little bit about tiers of storage. I want to get through this because I want to go through the cloud. One more poll and then we'll get into cloud. How much time do we have? 4 minutes. Let's not do this poll. Let's go right into cloud storage and unstructured data. So what we have is where does the cloud fit in here, and what's happening in the cloud side? Well, what's happening is the data characteristics are changing. Everything I've told you about is basically constructed our storage and our storage devices in a block structure. But what's happening is I have images. I have the fastest growth are pictures and snapshots and EEGs and all kinds of pictures that are coming out of the different environments on the hospital environments, for instance. And it just is creating a problem to manage that in a block type of structure. So what we're seeing is the characteristics have changed and the need for cloud storage has changed too. The characteristics is I have to be able to use this in a pool environment. I need to be resilient, which means I need redundancy, but I don't want to overspend. It needs to expand and contract as I reduce that. I don't want to create multiple pictures in the environment and store it multiple times. I just want to store one picture one time, but I want to be able to find that picture when I need it, which is agile. And then I want to be able to pay for it when I use it. So if I'm not using it, don't want to pay for it. Features of unstructured data. It doesn't reside into traditional databases or data warehouses. It has its own internal structure that does not fit into any kind of relational block environment. It's generated by both humans and machines. So we have machines that are now generating data. Before on the data side, on the database side, it was humans that were creating it. Now we've got machine communication. We have machines that are creating things. We have test data. All that stuff is creating above and beyond what they are. And some examples are emails and chats and business documents itself, surveys, web content, sensory data that we have in the here's some an analyst view of where the green line represents where data is growing and how that unstructured data is growing relative to the structured data that we have. So we have a big problem coming up. Unstructured data is 60 unstructured growth is 60 to 80%. So instead of laying that data out in blocks, we want to lay it out in objects. So what you're starting to see is object-based storage. This object-based storage is like the JBOD we talked about earlier. It doesn't need a lot of the data that it has, that we need, that the arrays have today to do the block management. We need to create the object, and we need to get to that object, and that object is usually created with a version of metadata that's out that's attached to the object itself. And we can do that in a much more efficient way instead of trying to store it on the array-based storage that we have. This is where we're going from this unstructured storage, which is object-based disk. That object-based disk is made up of a root, which is the object itself. It's usually created over iSCSI or SCSI commands. It can be a collection of different objects, and we can partition those things. So we can have that root object that we have. There may be a picture of Dennis and George and Fred. However, the partition of that object is give me all the pictures that have Fred in it, and give me all the pictures that have Fred and Dennis in it. All those things are an object. We can store it all there so that I can actually search it and get that data differently. So in summary, I wanted to go over organizations need to scale their storage solutions. It needs to be elastic, it needs to be on demand, it needs to be automated. The storage actually needs to be shared, so we can share it across the storage, share the data across the storage that we have. It's good to have central management and reporting to reduce overhead, create some productivity increases, and a way to have end-to-end visibility to manage the increasing storage utilization rates that we have out there. The storage virtualization technologies such as online volume and file management and provisioning all should come from a single point of management. And then we want to eliminate the vendor lock-in that you typically see from the different vendors that are out there, so we can intelligently place the data on the right tier of storage, not on the right vendor of storage, to reduce our acquisition costs, and place the appropriate data on the appropriate storage platform. So if we have a lot of object data, let's not put it on block data. Let's put it on object storage, and that's where you're seeing the cloud come into play. Cloud is not an object storage repository, so that I can go to the cloud, and rather than try to build this internal to your organization, you can actually put it into the cloud and access objects into the cloud much more efficiently. From some cloud vendor. The webinar series, do you want to go through this, Margot, for us?
Sure. Can you flip the slide? Yeah. So if you're interested in learning more, we've got some classes coming up in Chicago and Phoenix in August and September. And then this last slide here will give you an idea of what the webinar series looks like for the remainder of the year. I want to thank you for your attendance, and thank you, Dennis, for your presentation this morning.
All right. My pleasure.
Thank you.